Hello everyone, welcome to my chemistry channel Bldash, short and sweet in chemistry. Now here I am going to explain the topic, that is fundamental concept in organic chemistry. This is for class 11th and 12th also. Now part 8, this is part 8 where I am going to explain resonance or a mesomeric effect. The question is, what do we mean by resonance or mesomeric effect? Now some organic compounds, that almost all organic compounds are explained by Lewis-Dot structure. That means the outer cell electrons are explained by the Lewis scientist, that is called Lewis-Dot structure. Now here some organic compounds, they cannot be explained by the help of Lewis-Dot structure, and also the properties of that compound, that organic compound, cannot be explained by the help of Lewis-Dot structure, and also the position, it is not as a position to explain all the properties of that compound. Here the question, the resonance arises. Then what is resonance? One molecular formula but different structure called resonating or contributing or canonical structure. Then molecular formula remains same, but different structure called resonating structure, canonical structure or contributing structure you are telling. Then what is the meaning? So the compound cannot be represented by any one structure. Suppose benzene has not only one structure, there are two structures. Similarly, most organic compounds, they cannot be explained by the properly one structure, two structure. Then here the compounds, that is one specific structure is there, because you cannot explain. Suppose there are three canonical structure, which one is correct? That is why this is represented by other structure, and that is called hybrid structure. That is called hybrid intermediate structure, or it is called resonance hybrid. And this phenomenon, that is proceeding, that is called resonance or mesomerism. Again I want to tell, the molecular formula remains same, but there are different structures. It is called resonating, contributing or canonical structure. After you finding the Lewis-Dot structure, which cannot be explained properly, and now it is not explained by any canonical structure. That is why it is represented by a hybrid intermediate structure, and this is called resonance hybrid. And the process is called resonance or mesomerism. Notation. Now see, this type of notation that is used for your resonance. So here you can see resonance structure can be explained by this notation. So again you can see the examples. You want to see the examples. Now in examples, specifically it is taken as benzene, because benzene is very simple. Now benzene structure, that is developed by Kekulé scientist, and now here benzene contains alternative single bond and double bond. So what is that? C6H6. Here the single bond also there, and this is the double bond also there, but here what happened? They are in alternate position. This is called conjugated system. Now you can see here, that means you can observe what is the benzene structure. So if you say only simple benzene, which cannot be explained its property, characteristic properties, so that is why experimentally it is observed, it is in benzene all carbon bonds are identical. When you see the benzene, alternative single bond, double bond mean alkene character, single bond mean that is alkane character, that means saturated and unsaturated character. But here in experimentally proved that benzene all carbon bonds are identical. There is no difference. There is no showing properties of double and single bond. And what you observe? What is the observation? Same bond length of 1.39 angstrom. Not active. not active, just like unsaturated hydrocarbon, double bond present, because it is undergoing resonance and there is identical bonds, it is stable, no addition. If double bond there, then addition reaction possible, but here no addition reaction possible, because here bonds are identical. Bonds are identical. It is, that is why it is stable. No Lewis structure also there. Lewis structures cannot explain all the properties of the benzene. So canonical structures are there. After canonical structure, one resonance hybrid structure is there, and that is why it is very stable. No addition reaction, no Lewis structure are here possible. So see, it is called Kekulé structure, and this is the resonance structure of benzene, and this is the resonance hybrid structure. See this one and this one. This is called resonance hybrid structure. So here you can see, if the benzene is very easy, it can be explained in a very easy way, because here alternative double bonds are there, single bond and double bonds are there. When you come to second now see the second example, that is carbon dioxide, and here it is the Lewis dot structure, where two pair of electron on oxygen, this left side and right side also, two pair of electron, there are two double bonds here middle the carbon is there, and the bond length would be 122 picometer, which is theoretical, but when you go to experimentally, it is found that is 115 picometer. Now then, what is the resonance structure of carbon dioxide? Now here this electron, pair of electron from pi bond can comes to this side oxygen, and that is why it occupies negative charge and acquire negative charge and having 6 electron, and this side also two pair of electron come to this double bond, so it occupies 3 bonds and having positive sign on the oxygen, and these are the one structure. And again, if you exchange this one, this occupies oxygen plus and this occupies oxygen minus, then you can see, only you can write here O plus having 1 pair electron, and that is 3 bond here also, carbon, oxygen, and this part come to here, the last right side. This is the resonance hybrid structure. Then what happened here, the actual structure of the compound is a resonance hybrid of the compound. When you find that there are so many structure, canonical structure, and also lastly you conclude what is the resonance hybrid structure. The resonance structure are only hypothetical. You can't say that is okay. Actually, scientists found the answer of different question regarding through the resonance hybrid structure, and which are hypothetical. And the resonance structure never represent any real structure. Mind it, it is only hypothetical, never represent any real structure. So it is very, very important, it never gives real structure. Benzene has canonical structure, you know the canonical structure, and one is a resonance hybrid structure, I told before. Resonance energy, then what is the meaning of resonance energy? I told there are canonical structures, one is out of one and you find another one, new one, that is called resonance hybrid structure. And all are resonance structure, one is resonance hybrid structure. Energy of the actual structure, the molecule resonance structure, and is lower than that of the canonical structure, that is which is the resonance hybrid structure, which is the hybrid structure, and here, and that is lower than the all which structure, canonical structure. Now you can find here lower than any canonical structures. The difference energy between, because I told one is resonance means hybrid structure, another canonical structure, then here the energy of the actual structure resonance hybrid is lower than that any canonical structure, just like benzene, two canonical structure and one is resonance hybrid structure. So the energy of the actually resonance hybrid always lower than that of any canonical structure. more contributing structure. Suppose one is showing 2 canonical structure and other is showing 6 canonical structure, that means the more is the resonance energy. If more structure, then more energy. If the charge density decreases, then what is called charge density? If the charge density decreases, the energy of the hybrid decreases or its stability increases. That means whenever the hybrid structure energy decreases, then the stability increases. If the charge density increases, just oppositely it is happening. So you should remember, if charge density decreases, the energy of the hybrid decreases and its stability increases. When the energy decreases, stability increases. This is very important. Energy decreases, stability increases. Like this, any cross question may ask in a different type of multiple choice question. So what is the charge density? That means electronic charge per unit area. Electronic charge per unit area. You take area of the surface, or you take per unit volume of the field or a body. Take per unit volume or per surface area. Then what happened? This is called charge density. Here field or body, or you can say directly easy way, the ratio of an ions charge. Ions charge you know everywhere, copper +2, like this, potassium +1, ion charge and to its volume. That means charge by volume is called charge density. So here I told charge density increases, decreases, like all the things. So here what is charge density? Clear, no confusion. Charge by volume is the charge density. Rules for writing resonance structure. Rules for in previous video, all the rules of resonance structure I have explained, but here only in short form I want to tell. The resonance structures have the same position of the nuclei. Here nuclei will not change, nuclei position should be in the same, because nucleus is one which indicates the atom, what is the element. So that is why the position of nuclei is not changed. The same number of unpaired electron. If you see the electron number also, unpaired electron, if it containing unpaired electron, you should see it always remains same in any canonical structure. The contributing structures have the same energy. If there are two contributing or canonical structure have the same energy. And here atom should have octet rule. Atom, you know, each and every atom always satisfy the octet rule, that outer shell electron should satisfy the octet rule, mean 8. 8 mean, that mean lastly P6. So atoms should have the octet of the electron, means satisfy the octet rule. It is very, very important. I have already explained in our previous video resonance. The major resonance has the lowest energy, more number of covalent bond. That means which is the good resonance? If it is lowest energy, if it has more covalent bond, that means it has more canonical structures. Octet rule of all atoms. Octet rule means outer shell electron should be satisfied by 8, and that is called octet rule, should be satisfied. Less separation of opposite charge. When opposite charge is there plus and minus, then the separation between the two charge should be small distance, should be less separation. And you know, one should be more electronegative atom and other should be more positive atom. If that is more electronegative atom, it has a tendency, it occupies less negative charge. If it has less electronegative, then it has positive charge and more disperse of charge over 2 or more atoms. Not only one atom occupies the different charges, more disperse charge over the 2 or more atoms. So conclusion here, what is the conclusion? The single and double bonds are present in alternately in molecule. Generally you can find here alternative double and single bond, otherwise resonance is not possible in a aliphatic compound. And so here you can find this is one 3-butadiene. It is 1,3-butadiene. And here you can observe double bond, single bond, double bond, and it is aliphatic compound. And here the possibility, that means full possibility of resonance structure. The polarity produced in the molecule, that means automatically polarity will produce. What is polarity? That means one side positive charge, small positive charge, other side small negative charge, and in the molecule interaction of two pi bonds. Then here what happened? When positive negative charge form, but it is totally different from inductive effect. Inductive effect and the meaning, and here the resonance meaning totally different. And what happened in of two pi bonds and between a pi bond? So how the polarity produced? Polarity is produced between two double bond or between a pi bond and lone pair of electron. So you can find the polarity here existing. Polarity is formed, but here the between two pi bonds or one pi bond and other lone pair of electron on an adjacent atom, near the atom, and transmitted through the chain. If it is a suppose 4 carbon, now automatically it is transmitted in the chain. So the polarity, how it is produced? Between pair. How it is produced? Between pi electron or between pi electron and lone pair of electron on the adjacent atom and transmitted through the chain. Resonance is significant for the compound having. Resonance, where is possible, where you can say yes, resonance I can draw the structure. That means where there is an alternative sigma and pi bond. If there is no alternative sigma pi bond, the resonance structure is not possible. The electron can also flow, and other one, electron can flow from one part to the system to the other due to resonance. So when resonance occurs, the electron can flow from one carbon to other carbon, or you can say one part of the system to other due to resonance only. Then you can say, okay, resonance is correct. The presence of alternative single double bond in an open chain or cyclic. You can find resonance in a cyclic, that means benzene structure also, benzene substituted benzene also it occurs. That is why you can sure that alternate single double bond present in an open chain, that is aliphatic cyclic system. Example is your benzene. Then only you can say resonance occurs. So here this alternated double and single bond is called what? Resonance, that is conjugated system. And here pi electrons are delocalized. Then what happened about pi electrons? That when pi electron, you know, there is very weak bond. So it is delocalized and the system develops polarity. When the polarity existing, why the polarity existing? When the conjugated system is there, resonance is possible, and here pi electrons are delocalized and develop a polarity. Types of resonance effect. You know what are the resonance effect types? And it is called also mesomeric effect. So there are two types. One is positive resonance effect and other one is negative resonance effect. So what is that one? Positive. So it is very important. Positive, that is called plus R. Negative, that is called minus R. Plus R effect is also called plus MF. M mean mesomeric. M mean mesomeric. And here also it is minus mean mesomeric, minus negative mesomeric and positive mesomeric. And now I will explain what is positive resonance effect. Positive resonance effect, what is mean? You know, it should be positive value, it should be positive R should be written, but what is the meaning? Movement of electrons, you know, when resonance occurs, movement of electron takes place from pi bond. In a conjugated system that is having pi and sigma bond in alternate condition, that is called conjugated system, and here it develops positive and negative charge respectively. When it is a conjugated system, when there is a double and a single bond alternatively present, then what happens here? Here that movement of electron takes place. When electron takes place, when there is a pi bond, the pi bond that you know that is very weak, so here electron movement takes place. Resonance effect also called mesomeric effect, that is plus or and plus m, and what is that? If the substituent has a tendency to donate electron, you know what is the type it is called. If a substituent donate electron, that is called plus I. It is called plus I. So, if it is called plus I to the double bond and conjugated system, then what happened? Then it is called plus R effect. You know plus I mean inductive effect, but here positive I radicals. Positive I radical means here CH3 man important. The substituent has a tendency to donate electron to the double bond or conjugated system. Electron, if substituent can give, then it is called plus R effect. So, here if a substituent has a tendency to donate electron, so I can here the properly the word plus I not required, because here the other parts is not coming. So, only remember that here in the structure which substituent can give electron to the conjugated system mean the in the structure double bond present. Then here you can see, then what is the example? In example you can understand properly. So, if I come to the example, here displacement of electron pair is always from it, pair is away from it, dur jana. So, what is the effect is called positive resonance effect or plus or effect, or say displacement of the electron pair away from it. Now, see examples which are helpful. These are the substance, these are the called substituents. So, OH, OR, NH2, NHR, NR2, SR, X halogen. Now, you can observe here there are 2 pair of electron, 3 pair of electron present, and here what happens? Away from it, substituent say displacement of the electron pair is away from it. Now, see chlorine having 6 electron on the surrounding chlorine. So, this electron, 1 pair of electron come to the single bond. Here you can say, and if I say that double bond, that means 5 bond is there, 5 bond is very sensitive. That is why here the electron pair comes to here, that is why it comes to negative charge. Then here 3 pair of electron, 1 pair of electron comes to here, become double bond. See here a double bond, and it becomes double bond, it become minus sign. So, this is the structure. You can observe that how the electron displays away from it. So, here you can see the other example CH2, CH and H2. And what happened here? Here you can see double bond is there, NH2 substituent which can donate electron. Just now I told where plus R effect is possible, it is happening. So, here the electron when it goes from here to 5, always remember from 5 on to near the adjacent carbon, and here the substituent what will do? Donate electron to the adjacent bond. So, here you see since electron donating from here to here, the double bond changes to single bond, and here occupies minus sign. And similarly, from NH2 electron pair is coming to this side, this carbon. So, that is this part, this single bond, that is why it occupies double bond now. So, here this is the resonance hybrid structure. Now, you can see here electron jumps from to this is from to here, and this away from the substituent. And now it is cyclic, where it is called benzene aniline structure. So, what happened here? Aniline, this is called aniline. So, in alanine, NH2 that is donating nature, it donate the electron here, and this pair electron that is here a pi bond, that is electron comes to this carbon. So, see this occupies negative charge having 2 electron band comes from the amine group. So, here becomes to double bond, and here it becomes to that is minus charge having 1 pair of electron. And here again it is the localized, this pair of electron localized to this bond, and this pair electron from pi bond comes to this carbon. So it occupies negative charge having one pair of electron, and similarly here and it becomes a pair, it is a pi bond, it becomes pi bond. Again here this pi bond electron jumps to localize to this carbon, that is why it occupies a negative charge having one pair electron, and it occupies, it changes to, it comes localized to this bond, so it occupies pi bond. So this is the resonance structure. Resonance structure is very easy. Try to understand. Again see from amine. Amine is a substituent donating group, donating electron to this bond, and that is why it becomes to double bond. Since electron localized to here, it occupies positive charge, and here the pi bond is there, the pi bond very active, electron here jumps localized to this carbon, so it occupies, that is minus sign having pair of electron. Now since this pair of electron in second structure is localized to here, and automatically the pi bond it forces to next adjacent carbon, and the pi electron comes to this carbon, so it occupies minus sign having pair of electron, and here since it localized to this bond, it occupies a pi bond. And after that you can observe this comes to the localized to this bond and occupies a pi bond, and this again this one changes to minus sign having a pair of electron, because here this pair of electron comes and localized to this carbon. Now here this is the condition. Now after that it becomes a double bond, and this as it is, it comes to NH2. After this structure, one structure you can write this is NH2 double bond, and the structure is like this. So this is called aniline resonance structure. The transfer of electrons is away from one atom or substituted group attached to conjugated system. This electron displacement make certain position in the molecule high electron density. See here, this is high electron density, this is high electron, and this one. That means ortho and para positions are having high electron density. So that is why we put minus sign having this one. So next you see negative resonance effect. Now clear positive resonance effect, that is what is that one? Donating nature. And here this substituent is withdrawing nature and having double bond or conjugated system towards itself. Now it is coming towards itself. In plus R, what is that one? Away from the system, away from the substituent, and that is why it is called negative resonance effect. So what is resonance effect? This is towards it, the electron donating towards it. The transfer of electron is towards the atom and substituted group attached to conjugated system. System should be conjugated, and the transfer of electrons should be towards the atom or the substantial group. Then here minus R or minus F, minus M FX substituents. So you should remember what are the minus example of minus R substituent. NO2, nitro, carbon, CO, keto group, CH, aldehyde group, COO, R, and that is your what is that one? Ester group. So many you can observe here. You can observe COOR, this is ester, cyanide, keto group, nitro group, acid group. These are very good substituents having minus R substituent. And now example, suppose you know lastly this example, last what is present? Double bond O. That means here it is a aldehyde group and it is a minus R substituent. So here what happened? It is towards it. Towards it means it should come from other part of the system to the here aldehyde group is there, to the aldehyde where oxygen. Oxygen is more electronegative, and it comes from this double bond to here. And since it come here, the single bond, that is pi electron, pi bond is there, it comes to this carbon. See the structure CH2 plus single bond, and is double bond and single bond. See, it is double bond If I put a single bond, the satisfied is not satisfied by valency electron, not satisfied the carbon 4 valency. That is why this is the structure. If I will say ester group, this is called ester group. Second, see, the oxygen is more electronegative, other side is OCH3 group is there. One side oxygen, double bond O, CO group is there. So the pi bond electron should jump to this carbon, this double bond to oxygen. So see, here O changes to O minus, negative. And since the pi bond is there, that is why the pi electron localized to this bond, that is why it is a single, and here 1, 2, 3, and it should be occupies a double bond, because since the electron jumps from double bond to here, it should occupy that is double bond. Sorry, it is not double bond, it should, that here since the electron jumps here, this occupies double bond, not here. So I have to rub it because here the electron pair jumps from which carbon to which carbon we should observe. Otherwise, the resonance structure is very difficult to write. Always see carbon valence satisfied or not, the oxygen, the electron transfer from where to where. If where to where you should see the double bond or single bond should be. Otherwise, the resonance structure become wrong. You can never write the proper correct resonance structure. Nitrobenzene, that is a benzene structure, cyclic structure, and you can see same thing. This is pi bond comes to this side, pair of electron, and here also from this to this. That is why it occupies negative charge having 6 pair of electron. Simply you can write also negative charge, that is your choice. And here there is no change, only this part, because the pi bond electron localized to this bond, that is why double bond. And what happened here? In here, the pi bond that is changes to or localized to this carbon bond. Then here what happened? Becomes a single bond, and it is disturbed, and so here occupies positive charge. Then here it occupies positive charge because it localized to this bond, so positive charge will be removed, and here it occupies positive charge. And see here what happened? The positive charge, that means here you can write like this. If I will write like this, then what happened? So it becomes to double bond. Then what happened here? It occupies here now because this bond, pi bond, electron localized to this carbon-carbon bond, then here occupies a sigma bond and having positive sign here, because this bond localized, that is why here it occupies positive charge. You can observe here ortho position and para position are positive charge, having positive charge. By the resonance structure, one can easily understand the acidity of the organic compound, basicity of the organic compound. So many physical properties can be explained. Now the second we see the other examples, just like it is what is that 1,3-butadiene. You can see what here there are 2 double bond, 1 single bond. So from the beginning you see, because there is no proper substance, because all are carbon hydrogen, that is why you can observe where there is a double bond, here the electron jumps from here. The electron jumps from here to here, localized here, and similarly here also. That means it occupies positive charge and occupies negative charge. The single bond changes to double bond. See here, single bond changes to double bond. Say the electron from here, this pi bond localized to here occupies positive charge, and from here the double bond changes to single bond, negative charge. And similarly you can exchange the charge. Suppose from this side the electron changes, the transfer of electron changes, automatically this part occupies positive charge and this part occupies negative charge, and here it is a double bond. This is the beta 1,3-diene, or you can say 1,3-butadiene, the resonance structure. Similarly, any keto group, simply general formula of keto, the electron jumps here, localized from this pi bond to this, that is why it becomes single, and this carbon changes to plus sign, otherwise it has no meaning, because already the adjacent carbon, that is double bond, is already localized, that is why it occupies negative charge. Similarly, if you exchange this one, then what happens? If it is coming to plus 1, if there is one pair of electron less, and it occupies negative charge, because here what happened? This is more electron, so excess of a pair of electron, so it occupies negative charge. So these are the very good example you can understand easily. Then you will see difference between resonance effect and inductive effect. So here very almost all similar, but something regarding to double and single bond, it is different. Since it occupies it when resonance occurs when there is a conjugated system, and alternative single and double bond. And inductive effect, that is saturated bond, only what? Only it contains single bond. It contains single bond. So it contains single bond, and whereas here it contains alternative single or double bond, single or double bond, or not or, sorry, it is not a single bond and double bond. So it is not a single or double, it is only single and double bond, because it is a conjugated system. It is a conjugate. What is conjugate system? I told conjugated sheet means alternative double and single bond. So it is not necessary to write simply, otherwise it may confuse alternative double bond. And now here transfer of pi electron, where? R effect. You observe in different example, pi electrons are localized, transferred, but here sigma electrons. Then delocalization of electron, here what happened? Delocalized movement of electron takes place from one place to other, that is called delocalization. And no delocalization, it is in a chain, it is continued. So no change in charge density. When a R effect, charge density, there is no change of value and decreases away from the atom, from the initial polar bond. Here decreases when you see in a inductive effect, if it is a long chain of carbon, then what happens depends on the alkyl group, which is donating group, and if you say there is a withdrawing group, you can observe and how it decreases away from the initial polar atom. Now you can see what I want to tell, the here inductive effect, how it is taking place. See, this is the chlorine there, minus delta, and the gradually plus delta, plus 2 delta, and plus 3 delta. Here also 1 delta is there. That means it depends on the charge density, where it is not depending on in charge density in our OH resonance effect. See, this is called Kekulé structure, and see, this is the resonance hybrid structure. I told according to the resonance energy, the energy of third, that resonance hybrid, is lower than 1 or 2, that is a canonical structures. So I hope you can understand easily when you read this one, when you see this one, try to understand. If any problem comes, then refer inductive effect also, electromagnetic effect also, all are interrelated. And after reading all, after seeing the video of inductive effect, electromagnetic effect, all the things, then only it is very easy as resonance effect. So I hope you will subscribe my channel Bldash short and sweet in chemistry. Thanks for watching my video. Thanks again.